So today we will be discussing about the snappy hex mesh in detail, and we will be doing the meshing using this snappy hex mesh dictionary. So is there any doubt regarding the last day session? If anyone has the doubt regarding the last day session, because there were some people who didn't install OpenFOAM yesterday. So if you have any clarifications regarding some of the things that we discussed yesterday, you can ask me now, or else we can directly move on to the machine. Okay. So moving on to our snappy hex mesh. So you might have seen some of the things about the snappy hex mesh dictionary. Hello, can you hear now? Is it audible? Okay. So today we will be discussing about the meshing using snappy hex mesh dictionary, and we'll be doing some hands-on sessions on the mesh refinement and on the layer addition and the geometry. Okay, so if you have any doubt regarding the last day session, you can ask me now, or else we can move on to the hands-on session. Yeah, then now, yeah, ask me, Anup. Anup, what is the doubt? Hello? Okay, I think Anup, are you there? Okay, let's continue. So now we have threefold. Okay, then please text that out, Anup. Yeah, in the case of symmetry, we can give that as a symmetry condition in the block mesh. That will be coming to that in the later part of the session while discussing about the block mesh in detail. Because in the last day session, we had discussed only about creating a block and giving some gradient or meshing in the block mesh. So below that we can see some of the patches that we need to name in the block mesh dictionary itself. So while coming on to that, we will be discussing. Okay, no? Okay. So now we are moving on to the meshing using Snappy Expression Dictionary. So we need to do 3 steps for meshing a geometry. The first one is to create a block mesh that we had done already yesterday. And the criteria for creating the block mesh is that the geometry should be inside that block mesh. Okay. So we should be careful about that while creating the block mesh. And the second point is we need to extract the features of the geometry. Okay, we need to extract the features of the geometry that we will be doing using a command called surface feature extract. And the third step will be dealing with the Snappy XMesh. And we have a lot of controls in the Snappy XMesh dictionary file. And we will be doing all those things for creating mesh. Okay, so we can try some things step by step. So the first thing that I am going to do is that we have a dictionary file called the surface feature extract dictionary. Okay, please open that. Please open that. And in the dictionary file that we had copied yesterday, that was from plans. So we can see name of the geometry on the top as flange.stl. Okay, this I had edited yesterday. So you can, in your system, you can find the geometry name as flange.stl. Okay, we need to extract the features of the geometry file that we had saved inside the trisurface folder. So the name of that file is full.stl. So we need to rename it as full.stl here. Okay, so please do. So please change the name into full.stl. Okay. And just save that. Okay, that's it. So now we have specified the geometry name or the file name of which we want to extract the features. Okay, so after executing a command, all the edges or all the surfaces will be saved as an edge mesh. Okay, so this edge mesh feature will be used in the case of snapping. Okay, so the command that needs to be executed is surface feature extract. So just open the terminal. Just open the terminal and specify the path. Specify the path to the our case file. So our case file is airfoil 2D. So just specify the path. Now it's inside airfoil 2D. And execute the command surface feature extract. Surface feature, F should be capital. Surface feature, sorry, there's a spelling mistake. Surface, F should be capital, then extract. Again, E should be capital. E should be capital. Surface feature extract and click enter. So now an edge mesh will be created inside the constant folder. An edge mesh will be created inside the constant folder. Okay. So we can see that edge mesh. So while opening the constant folder, we can see another folder called extended feature edge mesh. Okay. While opening to that, we can see full dot extended feature edge mesh that's been created inside the constant folder. So we'll be using that file. So, and is tracked. The command is surface feature extract. F should be capital and E should be capital. So we should give the command while the terminal or the path is inside our case file. Okay, so that should be inside the F1 2D folder and just execute the command. So this is the second. This is the second step or the second command that we are giving. Okay, yesterday we had given another command called block mesh. Okay, now this is the second command. On. So we'll be seeing many and open snappy expression dictionary. Okay. So please open that dictionary file, snappy hexmesh dictionary file. Okay, last day I had shown something, and please go through that file and see whether there is anything familiar to you from the last day session. Please go to the file, snappy hexmesh dictionary. There is some problem with that virtual box. Okay, anyways. So inside in the geometry file or the snappy expression dictionary file, we can see that we need to specify the name of the geometries at some instances. Okay, so please go through that, and we can see three steps at the beginning. Okay, we can see three steps at the beginning. That's for cancellation, refinement, or the snapping and adding layers. Okay, so by the meantime, I will show that presentation.
Hello, sir.
Yeah,
Sir, in this file also we have to convert all flange to full.
yeah, we need to convert all the plans to full. So we can start now. Sorry for the delay. See, in this case, we can see that there are three things that we need to specify in the beginning itself. One is castellated mesh, then snapping, and then add layers. Okay, so in the default, the first two things will be true, and the third one will be false. Okay, so we'll be trying all the different methods or keeping snapping as false or keeping add layers as false, and we just want to see what is the difference in meshing. Okay, so first of all, we can keep this castellated mesh as true, and the remaining two things, that snapping and add layers, as false. Okay, we can keep the remaining two things as false. Okay, so please do that and just see how we will be getting the mesh. Okay, so that's the first thing that we are going to do. And we need to specify the geometry in which we want to do the meshing. So just we want to give the name as full.stl. There's a geometry that we want to specify, and that's a tri-surface mesh, and the name of that mesh should be full. Okay, that will be flange in your case. We want to rename it as full. Now we can see something below that. We want to refine something. Okay, just that be there itself. We don't want to edit that. Please delete that. Okay, fine. Please delete it. We are going to delete this thing. In your case, I think that will be refine hole. Okay, you can see it as refine hole. Yeah, we can control meshing on each patch. Yesterday I had shown one thing by creating a plane. Okay, so we can control that using a 2D plane. So now just delete that refine hole. Okay, and just move on to the next steps. The castellated mesh controls we have. Now we are not changing that maximum local cells and the maximum global cells. We are keeping it as such. And also we are not doing anything with the minimum refinement cells or the number of cells between each levels, that we are keeping it as one itself. Okay, just we are changing some parameters, and let's see how the mesh will be coming. Okay, and then later on we can change one by one, and we can see how good the mesh or the how quality mesh we can generate from this. And now already we had created an edge mesh. So we need to specify the path name or the file name where this of the where the edge mesh is being created. Okay, so we are giving it as full dot extended feature edge mesh. So I had shown you that file that is already created inside the folder constant. And let's give the level as 2 so that more features will be extracted from that. Okay, so please do rename the flange as full dot extended feature edge mesh, and give the level as 2. Okay, now we are moving on to surface based refinement. So here on the surface we want to refine the mesh, and I am giving the level minimum and maximum as 2 itself. So the mesh will be created at the level 2. Okay, if you want to try different levels, we can give a range. We can give 1 to 3. Okay, so that the minimum level will be 1 and the maximum level will be 3. So we can change the levels. So as of now, I am giving the level as 2 itself. And the resolve feature angle, yesterday we had shown some figures regarding this resolve feature angle. If the angle is more than 90, obviously we cannot extract the features of the pipe. Anyways, we had kept it as 30 degree, or else we can keep it as 60 also, that doesn't matter, but that should be below 90, or else we won't be able to extract the features of the pipe. So keep that in mind. And while going for meshing the complex geometries, we should recheck again and again to see whether this resolve feature angle that we are given is okay. Because I had already specified the case of Nakarofel that we had discussed yesterday, that we want to specify the angle at the range of 10 degree only, then only we will be able to extract all the features. Sometimes we may have to go to the angle like 3 degree or 5 degree itself. Then only we will be able to extract all the features of that airfoil. So that we need some experimentation. Okay. By practice only we will be able to know what the angle should be given in that. So that depends on the geometry. So keep that in mind. Now, in the case of region-wise refinement, already we had deleted something in the beginning, that is a refinement hall. So here also we can see refinement regions is there, and inside that we can see a refine hall. In my case, that's renamed as refine pipe. So in your case, you can see it as a refine hall. So here also we want to delete this thing because we are not specifying it now. So keep the refinement region as such. Okay, please don't delete the braces also, or else that will show error. Okay, we are just deleting the commands that we are given inside that braces. Okay, so please keep in mind that we are deleting only the commands. We are not deleting entire thing. So that two braces should be there, or else that will cause error, and it's quite difficult for finding that where the error is there. Okay. Because that will be showing an error command like this. There was some error in castellated mesh beginning from the line, say suppose 40 to line 250. Okay, so we won't be able to know where the error actually lies. It will be showing a range of lines starting from 40 to 250. What to tell, be specific, and you should know what all things that you're doing, or if you are editing in Snap Dictionary, you should be aware about all the editions that you are made. The important part, we want to specify where is the location of mesh. Okay, we want to specify where is the location of mesh, where we want to mesh. So as of now, you can do one thing. Here I had already given the coordinate inside a pipe. Okay, so please give that points, coordinates, and later I will show how to get these coordinates. Okay, later on, when we move on to para view, I will show how to get these coordinates. So as of now, please type these things, coordinates. Okay, the values are 0, 0.05, and minus 0.02. Okay, I will type in the command box 0, 0.05, and minus 0.02. Okay, so these are the coordinates that we are giving x, y, z coordinate values. And this coordinate lies inside the pipe so that the meshing will happen inside the pipe. Later on, we can give the location outside the geometry also and see how the meshing is happening. Okay, now we are moving on to the snapping. As of now, we had kept the snapping as false, so the snapping will not occur. Okay, so save the dictionary file, and we don't want to close that because we want to edit it again and again. So save that. Now open the terminal again. Is it clear till now? Any clarification required? Okay. So now I am opening the terminal. I am opening the terminal and changing the path to our case file, that is airfoil 2D. And now I am executing the command snappy hex mesh. Snappy hex mesh space minus overwrite. Snappy hex mesh space minus override. In that H and M should be capital. Okay, and click enter. And now the machine starts. Okay, it will take some time for completing the machine. So here we are just meshing the geometry. We are not snapping that. So we won't be able to extract all the features of the pipe. Okay. So let's see how the mesh file looks like without this snapping process. Okay. Then later on we can make the snapping algorithm on, and we can do this mesh again and see how it look like. And then as a third step, we can switch on the add layers also, and we can add the layers to that. And then later we can see how the meshing outside the geometry occurs. Okay. So it will take some time. If you have any doubts regarding this, you can ask me now. It will take some 5 to 10 minutes. Mission completed in 7.11 seconds. Oh, that's good. It takes 103 seconds. That depends on the system. Okay. Because they send a virtual machine and having the RAM. So all these things will play an important role. We had allotted only 30 GB space for this entire OS Ubuntu. So anyways, that depends. Okay. Now we can open the para view.
Hello, sir.
Yeah, tell me.
So, sir, in the end, I just got a message like form fatal error, point 0.52 minus 0.02 is not inside the mesh or on a face edge.
Okay, can you please share your screen?
Can I share?
Please share your screen so that I can see that error.
Just
Srikumar?
hello, sir. Sir,
Yeah.
it's starting with my system
Okay,
just
okay.
hanging when I try to open the client. Like I was accessing the class through my phone and things in my laptop.
Oh, okay, okay, okay.
Just a second, I'm just opening. Hello, sir.
Yeah, tell me.
So how to share the screen also? Hello.
It's below okay. You can see to present the screen. Here you can see whether to
Hello.
start presenting at the bottom.
Hello.
Did you see that? Okay, one thing, Srikumar, did you check the surface yesterday? Did you execute the command surface check? Please move on. Okay, yeah,
Sir, sir,
yeah, tell me.
I was not getting your audio. I don't know.
You are not able to present that?
Yeah, is it showing?
Okay, and had you checked the surface yesterday? I had shown some command for checking the surface.
Yeah, I have done that.
Yeah, I have done.
And and you had seen that the geometry is closed, isn't it?
Yeah.
Yeah.
Yeah, okay. Okay, then please show that error.
So I'm presenting
Sir,
right
I'm
now.
presenting right
You are presenting, but I cannot see anything. Click on that present, and another window will be coming to ask you want to present the entire screen or not. That will be a pop-up in the top left corner. Yeah. The point zero is not inside the mesh or on the face edge. Bounding modes of the mesh. Yeah, I think you might not have changed the geometries.
Okay.
Okay, please show your tri-surface folder. Full.stl. And what about the snappy extension dictionary? Yeah, please move, scroll up. True, false, then please move on to the next step. In the case of geometry, full.stl. Okay, have you executed the command yesterday block mesh?
Yes, sir. I think I have a problem in running that, and you rectified that, right?
Yeah, then that's why it's showing the error. So do one thing, please go to the terminal and type the command block mesh, and let's see what's happening. Yeah, I think now it's okay. Now type surface feature expire. And do snappy X mesh. Snappy hex. There should not be any space in between. Snappy, no space.
Ah,
Okay,
yes.
snappy hex mesh. That should be a single word.
Okay.
and space minus override. That's it.
Oh, sorry,
Okay.
sir.
Yeah, it's done. That's it.
No, I haven't typed
Okay, sir.
minus
Yeah,
over.
yeah. Okay, you can do that. No problem. Okay, snapping instrument minus override. Just type enter. That's enough. Enter. Yeah, that's it. Yeah, that's it. Okay.
Okay, sir.
So the error was that because you didn't execute the command block mesh.
Okay, sir.
Okay. That's it. So now we can see whether the mesh, our our mesh, how it look like. Okay. So I am opening the para view. And opening that result.form. Okay, opening the result.form that we had created yesterday. And if anyone is new now, because those who have not able to do it yesterday, just execute that command in the terminal, touch filename.form, touch filename.form. Okay, I will give the command in the command box. So that should be given. And now we will be able to save all the results in that particular file. And we can open that file now and just see how our mesh look like. Just zoom to see. Oh, this was the previous mesh that I had created. Oh, this was a mesh that I had created already. I'll create it once again. It's not overrated. Please see how your mesh look like. And if anyone had got some horrible images, please do share your screen if possible.
Hello, sir. Sir, it will be a box, right?
Yeah, it will be like a box, yes. I'll do it once again. So if anyone is doing in the computer and who is having Google Meet also from computer, please share your screen. Please pin that Hriday Sridharan. Jidin, please pin Hriday Sridharan. You can see that presentation. The presentation is from the account of Hriday Sridharan. What it is. I am closing that. and executing the commands again. I'm moving on to the path. Then first command is block mesh. Then surface feature extract. And then snappy hex mesh minus override. So we'll be doing the meshing again. And now those who had completed this process and seen the meshing, you can do one more thing. You can see true. Okay, please do that and go ahead. Srikumar,
Yes.
can you please unmute? Sorry, can you please mute that? I can see you from two accounts. Sorry. Okay. Uh, yeah, I was telling those who had completed the machine can move on to the next step, that you can switch on the snap feature. That means you can keep the snap feature as true and do that meshing again so that you can see how the mesh look like after the snapping feature is kept on.
Should we want to close the paraview and do it once again?
Yeah, we want to close the paraview. Yes. See, this is the result that you had got. Okay, I'm making it a surface with edges so that you can see. And while zooming this, we can see that it is like a step-by-step like thing, and it doesn't have the curved feature of the pipe. So for extracting all those features, we want to do the snapping. Okay, the screen is being shared now. Nilesh, I can see that screen that's shared. See, you can see that step-by-step nature of the geometry. That curved feature is not being extracted. Okay. So this is how a geometry or the mesh file look like when the snapping feature is kept off. Okay. Now we are closing this paraview, and now we are making this snapping feature as true and doing the mesh again. Okay, we are keeping this snapping feature as on. That means snap should be made true. Okay, snapping should be made true. Save that. And then again, run snappy expression. Okay, again run snappy expression minus override. Again run snappy expression minus override. And let's see how the mesh is coming. Yeah, I think it's done now. Yeah, now we can open that using parallel view. See the figure. So it's more or less like our geometry itself, isn't it? So now we had extracted almost all the features of the pipe. Okay, now I will change it as edge surface with edges view so that we can see the edges also. So it's almost good, isn't it? But we need to add the layers also if you want to extract the features or the physics. We want to study the physics and the boundary layers and all. Because in one of our work, we used to um, study the phenomena that is occurring inside the pipe bends in a flow case. Uh, there occurs some secondary vortexes called beam circulation as well as line circulation. So that will be caused when the flow occurs in a pipe having some degree of angle bends. Okay. It might not be 90-degree bend. It can be some 35-degree, 40-degree, or 120-degree bend. So when the fluid passes through these pipe bends and all, there will be some secondary vortex being created in that. So while extracting all those features and we want to study in more detail about this vortex and all, we want to give layers at the surface because there will be some surface phenomena that will be occurring. So I'm getting just getting a box, not a pipe. So did you do the second step, Sri Kumar? Did you keep the snapping feature true?
Yes, sir, I have done that.
You have kept
Yeah.
the snapping feature true.
Yes, sir.
Okay, then do one thing. Just go to constant.
Okay, sir.
Just goes to constant, and you can see a folder called polymesh.
Yes, sir.
Just delete all that folder.
Delete folder
Yeah,
on the
yeah,
things
that
inside the phone.
delete that polymesh folder. Okay,
Okay.
delete that folder name polymesh.
Okay,
Okay,
sir, I have.
and then execute all the three commands. Start with block mesh.
Okay, sir.
Okay, and now we are again moving on to the next step that we want to add the layers. Okay, we want to add the layers. So that I am closing this para view. And closing this paraview. Again moving on to the snappy expression dictionary file and keeping this add layers as true. Keeping add layers as true. Okay. Keeping add layers as true. And then we need to move on to the add layers section. Just scroll down. Yeah, here starts the add layer controls. And you can see that by the default that will be named it as some flange underscore dot asterisk. Okay, that will be in double quotes. So we are changing that. We had given the name as wall. We want to add layers to the wall only. So already the patch name is wall. Okay, the patch name is wall. We have three patches now. That is, one is inlet, outlet, and wall. Okay, we want to add layers onto the patch wall. So we are specifying that in the geometry full, there is a patch named wall. In that patch, we want to add 10 layers. Okay, we want to add 10 layers. So that's what I had specified here. The command is full underscore wall. That should be kept in double quotes. And we want to add the number of layers inside the braces. Okay. So I'm giving 10 layers now. I'm giving 10 layers now. And the expansion ratio is given us 1. We can change the expansion ratio to 1.2. We can change the expansion ratio to 1.2. Okay, change the expansion ratio to 1.2. Save that. Okay, now execute the command once again. Now we once again. So for executing the command, no need of typing it again and again, just click on the up arrow key so that it will be showing the previous commands that we had used. Okay, so just click up arrow key, and once this command came onto the terminal, just click enter. So now we are adding the layers also so that it will take some more time for the machine.
Hello, sir.
Yeah,
Sir, I'm still getting
you're still getting
a box.
that boxes only.
Yes, sir.
Oh, can you please share the screen?
Sir, is it possible?
Yeah, that's visible. So no, the machine is not occurring now. So please change it as wireframe. So we cannot see the pipe inside, isn't it?
Yes, sir. Will that
Like, is there any some clues of the pipe wall or something like that you can see? You cannot see anything. That's why I'm asking.
is this
No,
sound?
no, nothing is there. No. Yeah, okay. So that means the machine is not happening in your case.
Yesterday also I was just getting only a plane like while doing the block punch. I tried again and again. Like it was just a plane, not a box. And the pipe when I import, we should be opening the pipe geometry right here.
Yeah, okay.
So in that time also like I was getting one tab over here only. Like I like the screen is getting freezed. Nothing was
Okay.
coming.
So please open that geometry also now type. Oh, no, inside. Mm, okay, now it's look good. Okay, do one thing. Please delete that polymesh folder again. Okay, then type block mesh.
So it's fine.
Uh, there are no merge patches. Yes, it is writing polymesh information. It's created now. Now, please open that using Paraview.
Now it's coming.
Yeah, the block is there. Yeah, that's fine.
Now I have to have like the geometry should be
And
there.
yeah, now something is yeah. Okay, okay, that's fine. That's fine. Please close the. Please delete that folder called one also.
Okay, sir.
Okay. That folder one is created since you didn't give the command minus overwrite.
Okay, sir. So is it okay?
Yeah, now it's okay. That's
So I
fine.
have to just close that, right?
Yeah, just close that and you can delete that folder one also. Please delete that folder one.
Yes, sir. I have deleted that.
Okay, fine. Okay, fine. Now move on to the next step.
Should be
Surface user extract.
surface.
Yeah. Yes, yes.
So
Yeah,
like this
now do
execution.
snappy expression. Yeah, that's it. Snappy expression. Yeah, yeah.
So why this out results comes?
That's just due to some graphical error. That doesn't matter.
Okay.
So again, that's box. That's box. No,
Yes, sir.
no need to look. So we can do one thing. We can look after the session because it will take time, I think.
Okay.
Okay. So yeah, probably in the afternoon session we can have much discussion on that. Okay.
Okay.
So now we had created. Oh, I'll present it once again. Yeah. Now we had create the mesh. Just open that mesh file. That's almost done. And now, if we take the section, because we need to see how this meshing is occurring, but we need to take a slice of that. So just click on the result file, click on the result file, and just above that, you can see a slice icon for slicing the geometry. So just click on that, just click on that, and by keeping this slice plane selected. Click on the slice so that that plane will be selected. You can see a red rectangle or there. That's a plane where we are going to slice. So keep that in the Z direction normal. Okay. Keep that in the Z direction normal. Just scroll down the properties and you can find that. So click on the Z normal. Click on the Z normal. Okay. And then click apply. And then click apply. So we slice the plane over there, and just I am changing that into surface with edges so that we can visualize the layers also. And just now the slicing plane also is being shown. That means that red color plane is also shown. That we want to hide that. So just uncheck the box show plane. Okay, just uncheck the box show plane. And now you can zoom that. Okay, now you can zoom that and you can see that many layers are being added onto that. Okay, many layers are being added onto that. You can see that. So this is how we are adding the layers. Okay, this is how we are adding the layers into the geometry. So if we can add the layers by patch. Okay, sometimes we don't want to add layers in some patches so that we cannot. We don't want to specify those names. We only want to specify the names at which we want to add the layers only. Okay, so this is about the add layers. Now we want to refine the geometry. Now we want to refine the geometry. So again, we are going back to ParaView, sorry, Snappy Hex Mesh. So I'm just closing the ParaView, again going back to the Snappy Hex Mesh dictionary, and I'll show the thing that I had made initially. Just look into that. Just look into that. I am just renamed it as a refine pipe. Okay, because we are going to refine a pipe. We are going to refine a pipe. So that's why I named it as refine pipe. And refinement regions that we will be giving. I'll show it once again. See, these were the refinement regions that we were giving. So one was the searchable box, and in this you can see the format on how to give the searchable box. So since our pipe geometry is more close to that cylinder, I am specifying it as searchable cylinder. Okay, so the format for giving the searchable cylinder is the point 1 and 2, where they are the extreme ends of the cylinder. That means the center point, the axis. Okay. and we can specify the radius also. So the extreme ends or the extreme points of the axis is point 1 and point 2, and we can specify the radius. So an imaginary cylinder with this geometry will be created, and those regions enclosed inside the cylinder will be refined. Okay, those regions that is kept inside this invisible cylinder or the imaginary cylinder will be getting refined. Okay, so I'm giving the values. I'm giving the values as point 1 is minus 0.05, then y direction. The y direction is being changing so that the axis is parallel to the y axis. Okay, axis is parallel to the axis of the cylinder is parallel to y axis. So please specify these things in your dictionary file. Okay, I will be discussing all these things, how to get the coordinates or how to find the coordinates using paraview shortly. So as of now, just give these points and then we can move on to next. So the point 1 is given as minus 0.05, minus 0.04 and 0. Then point 2 is given as minus 0.05, minus 0.1 and 0. And the radius is given as 0.05. And the radius is given as 0.05. So now we can move on to the next step for giving the number of elements that we want to give. Okay. So just scroll down and you can see the command that you had deleted early. That's the refinement regions. There, just type these things: refine pipe, and the mode is inside because we want to uh, what to tell. We want to refine the region that is enclosed inside that particular cylinder. We want to refine that region inside the cylinder. So just give the mode as inside and the level is given as 1E50 into 3. Okay. So that is the number of global elements as well as the level that we need to specify. So please give that. And once you had completed this, just give that snappy xmesh command once again. Okay, just give that snappy xmesh command once again. So I'm just saving this one and moving on to the terminal again. And giving the command snappy hex mesh space minus override. Okay, so that will add refinement to some regions also.
Sir, can you show me the dictionary? I haven't completed
Yeah, yes. So we had got one error also now. So mostly we'll be coming across with the same error. So I'll after this I will show you what is that error, okay, or how to rectify that error.
Sir, I have completed.
Okay. So see, we had got an error message like this. So machine was occurring, and finally they will show some numbers. Let's see. we can see that cell in cell 23925 in the top. We can see that in cell 2395. I'm not able to scroll up. Okay, I'll execute this command once again. See, after executing this command, this machine will be running and it will show that previously we have this much a number of elements. Previously we have this much a number of C. In this we can see that cell 23925 of level 2 uses more than 8 points of equal of lower level points. And they will be showing something. And there won't be any relation with the codes that we had given. Okay. And there will be lot of question marks. There are a lot of question marks also. So we won't be in a position to rectify this error because we don't know from where the error is occurring. There is no specification about that. Okay. So the error is just caused because of the previous mesh file that is created. Okay, the error is caused just because of the previous mesh file that is created. So in these cases, if it appears like this, what we want to do is that we want to delete the mesh that is already created, and we should start from the beginning. Okay, that means we should start from the block mesh itself. Okay, so that's what we want to do. So first of all, I am going back to the our case file. I'm going back to the case file, and in that the mesh file will be saved inside polymesh. Okay, the mesh file will be saved inside the polymesh. So what I am doing is that I am just deleting that folder. Actually, there is no need of deleting the entire folder. We can delete the mesh file only, but that's okay. For the sake of easiness, we are just deleting the entire folder. So I am deleting that. And now I am going to execute this command again. Okay, now I am going to execute this command again. So we should start from block mesh. Okay, we should start from block mesh. So just start from block mesh. Now again surface feature extract and finally snappy exmesh.
Sir, hello.
Yeah.
Sir, can you just show me the first command, like refine file? Sir, in that, like we are entering the commands, right? So, should the position should be in a order, like in a line? Uh, like will that cause an error?
No, that doesn't matter. It doesn't should be in a line, but we want to specify an axis. Okay, so the axis, if it's not vertical, the cylinder will be an inclined one, and all those portions enclosing the cylinder will get refined. That's all.
Okay. Sir, can you show me?
Yeah, I will show that. Yeah. So this is a vertical cylinder that is parallel to the y-axis.
Okay, sir. Thank you.
Okay, now let's see whether it is executed or not. No, it's been done. So, uh, I think these are some of the main features of Snappy Hex Mesh, and see how easy we can do these controls. But there will be some errors occurring if we make some mistakes, and that will be quite difficult for us to rectify in the beginning. As a beginner, it's quite difficult to identify where this error is occurring. Okay, so by doing by your own, uh, you may come across with many errors because there will be some careless mistakes. Sometimes we'll be forgetting to keep one semicolon, or unknowingly we'll be deleting one brace. So that will be showing the errors. So actually we should do it by our own, or we should try to do it without any guidance from anyone, and just see how you can perform. Okay, and you should be in a position to know what all errors are occurring, and if that error occurs, how to identify and rectify all those things that we need to know, and we need to study all those things by only practicing. Okay, so keep doing practicing, because actually using the snappy X mesh, that's very easy for machine, but there should be some sort of controls that we need to give. Okay, so that's the main problem with this snappy X mesh. But anyways, once if we are mastering this one, we will be able to create good quality meshes. Okay, so in my experience, this machine using snappy X mesh is very easy when compared with that machine using Fluent. Because I've been working only with this Fluent and OpenFOAM. So there are a lot of controls are there in the case of Fluent also, but I feel uncomfortable with that machine. Is there anyone who had completed the machine?
Yes, sir.
And had you checked that refinement portion?
Not yet, sir. Last time it wasn't showing correct. I missed one step there, so I have not
Oh,
tried it this time.
what was the step?
Sir, I missed the step like slicing one last time,
Okay, okay,
matlab
okay.
in the previous section, so I
Oh,
didn't tried it. I'm waiting for you to tell.
okay, 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 okay. Yeah, now it's complete. Yeah, in the parallel machine, we want to give the command. I'll show you that. We want to snappy expression minus overwrite and we want to give it as space minus parallel. Okay, so that will be doing that parallelly. So that's the command that we need to execute for meshing in parallel. Yeah, now yeah, actually we want to decompose par for the running purpose only. Okay, once we will be getting the mesh geometry and then we will be doing the decompose part dictionary for decomposing that mesh file that we had got. Then we'll be running for getting the solution and finally we will be reconstructing that again. Okay, we'll be reconstructing that again. That also will be used for the decompose part dictionary will be used for reconstructing the geometry again. And finally we'll be getting the results. So yeah. Now we are opening the para view and opening that. And then click apply. I'm not able to click onto that. Again, some problem. I'm just restarting this again. Something happened to the virtual box. Oh, okay, 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 okay. So at last you had find the error. That's good. Okay. Now, now just open the terminal. So those who had completed can use this. Open the para view and see how the mesh look like. Okay. Uh, 2D. So I have just opened that mesh file. And now I'm just clicking onto that result.form in the pipeline browser. And then above that, we can see some tools for plotting a contour, then for clipping a geometry, that means we can cut a section of the geometry, and here we can slice the geometry. Okay, so I am going to slice the mesh geometry that we had got. Okay, so just click on to that. So in the pipeline browser, the slice appears. So by keeping the slice selected, click on apply. Okay, so that, sorry, now it was, I'm just deleting that. I will do it once again. So actually now this was perpendicular. The slicing plane was perpendicular to the x direction. Okay, this towards right is the x direction. Towards the right is the x direction. So this slicing plane was perpendicular to the x direction. Okay, you can see it now. So it was actually perpendicular to x direction. I want to see the entire geometry sliced into half. So I am changing the plane as perpendicular to z direction. Okay, I am changing the plane as perpendicular to z direction. So just scroll down that property tab and we can see three buttons like X normal, Y normal, and Z normal. Okay, so click on to that Z normal. Click on to that Z normal so that the plane becomes perpendicular to Z axis. Okay, then click on apply. So now we had sliced the plane. We can see that sliced plane. Then just I am scrolling up this property tab and I can see a box with that is checked. That's a checkbox now that we can show that plane or the slicing plane. The slicing plane means that plane that is in the red color. Okay. So when I move the this mouse pointer, I can see that a plane is there. Okay. There's a plane over there. So I'm just closing that. Okay, I don't want to see that slicing plane. I just want to see the slice of the geometry only. Okay, so just uncheck that plane. Just uncheck that plane. So now we can visible only the sliced geometry. Okay, So now I'm changing that onto surface with edges so that we can see that meshes that we had already created. So now just zoom on to that area where the refined meshes are created. See, we can see that the layer is added. The layer is added on the pipe board, and there is a specific area over here. There is a specific area over here where the mesh is refined. Okay, where the mesh is refined, there is a specific area over here. So here was our cylinder, the refinement region or the refinement region for that particular invisible cylinder was being created. So this was the height of that cylinder, and all those regions that was enclosed in the refined cylinder is being refined now. Okay, so the mesh is being refined now over there. So please zoom on to that, and you can see the difference in the meshes. Okay. Okay, that's it. So, do you have any doubt regarding these things? So now we had created the geometry, then done some pre-processing in the geometry, created the block mesh, and finally now we had meshed the geometry. Okay, do you have any doubts till now?
So
Yeah,
we had to mesh the entire body or just the walls?
we want to mesh the entire body. Actually, we had meshed the entire pipe now. Okay, we had meshed the entire pipe now, and then now we had add layers to the walls. We had add layers to the walls, and also we had given some refinement to a particular area. Okay, now we had given refinement to a particular area.
Hmm.
Okay, that's what we have done in this case. Because in some of our cases, if we are doing some complicated geometries and all, we should refine some of the areas of that particular geometry. Okay, or else we won't be able to analyze it properly. So we need to specify some refinement regions and all. So I just show an example how we can refine a particular region. Okay, in the case of pipe, that's not it's not necessary to refine a particular region because there is nothing irregular in the order.
Thank you, sir.
So you can see that the some of the regions are refined very with very small size meshes. Okay, so that's it about the meshing part. Now we'll be dealing with how we can mesh the outside the domain. That's one thing that's remaining, and the other two things: how we can get the coordinates of a point that lies inside the geometry. Okay, how we need to get that points. Let's see.
So
Yeah, tell me.
how we decided that this point needs to be extra meshed like in this one?
I didn't get you. I didn't get you. Nilesh,
So I
what
mean,
was it?
like in the some area they are densely meshed. Then how we decided that this part needs to be dense meshed,
Yeah,
densely meshed?
that I had shown arbitrarily only. Uh, okay. Suppose there was there was a swirler over there. Okay. In that particular location, there was a swirler over there, and we need to give refined mesh over there. Okay, in that particular case, we know the position of that solar, so that we need to specify those locations so that it will be getting refined at the particular area. In this particular case, we don't have anything to refine. So I just choose the coordinates arbitrarily, and I had given some radius also in that particular cylinder. The radius given was 0.05 meter, and I
0.05.
had created a cylinder and given a refinement. That's it.
Okay.
Okay.
Thank you, sir.
Okay. So actually, in your case, if we have some region where we need to give some refinements, then actually we need to specify the locations. So for that particular purpose, we need to know where the geometry or the refinement region should be given. Okay, so that we need to identify the coordinates that we can do using ParaView. So we can visualize the coordinates, or we can give some. There is a ball shaped thing will be there in that figure. I will show that. So just moving on that board shape figure, we will be able to locate the coordinates of that particular point, and thus we can identify the location where we want to start with the refinement, or what's the region where we want to specify the refinement, or what are the coordinates that's inside the geometry, and what are the coordinates that is outside the geometry, like this. Okay. So let's see how it look like. I'll show you. So the first thing that you want to do is that I'm just deleting the slice that we had created now. I'm just deleting the slice that we had created now, and moving on to form, that result file. Now just I'm getting this slice once again. Okay, I'm just getting slice once again. Just I want to zoom out. Yeah. Now we can see there is a one ball is here. Okay. So that's the origin of that plane. That's the origin of that plane. So what I used to do is that just move this plane. Okay. Just move this plane, and now suppose that it's in the center portion of. Okay. Now it's in the center portion of that particular area. Yeah. Now we want to move it a little bit also. Yeah. Mostly now it's in the center. Okay. So that the so this is the y direction. This is the y direction. No, sorry. Uh, I think, yeah, that's a y direction. Yes. So that's in the y direction. So now we can tell that that origin is lying at the center of that particular area. Okay, at the center of that particular area, and the origin is specified here. Okay, we can see the origin here. We can see the coordinates of the origin here, x, y, and z coordinates. Okay, we can see the x, y, and z coordinates of that. So by using these coordinates, now we can tell that that particular coordinate is lying inside the geometry. Okay, that particular coordinate is lying inside the geometry. So this is how we are choosing a particular point inside the geometry. Okay, now suppose we want to refine a particular area. So we might be knowing there are some irregularities over there, and we might be knowing the location, but we don't know the coordinates. Okay, we don't know the coordinates. So the easy way is that uh, we can just move this plane where we want to refine that, and we can move this origin also. Suppose we want to refine the pipe from here. Okay, we want to refine the pipe from here, but now the origin is here. So just move that origin, just click on the origin and just move that. Okay, just move that origin. So now we can see that the origin is lying inside. Okay, the origin is lying inside that one. So likewise, just move on to that and we will be able to locate a particular point. Okay, just move that and we will be able to locate a particular point. So by that, we will be having some ideas. We'll be having some ideas about the geometry, about the dimensions of the geometry that we had created. So by using that, just give some points. So in the origin, I am giving the values as 0.03, 0.03 in the x, and here it's given as 0.06, 0.06, and in the z, it's specified as 0.015. Okay, so I'll show that. I'm just changing that into wireframe. See, almost it's lying inside the geometry, isn't it? That point is lying inside the geometry. And now this is the point. Okay, but that's not in the center. So what should we want to change? We want to change that in the y direction, I think, yes. In the y direction, we want to make some changes. So I'm giving the values as, oh, not in the y direction, the z direction. So I'm giving the value 0. Okay. In the z, I am keeping it as 0. Yeah, now it's all in the middle. Okay. Now it's in the middle. So like this, so now we had got a coordinate that's 0.03, 0.06 and 0. Okay, 0.03, 0.06 and 0. So like this, we can locate the geometries from where we want to start the refinement and till where we want to give the refinement. Okay, so this is how we are doing by seeing the geometry. Okay, by seeing the geometry, we can do those things. And if you know the dimensions of the geometry that is being created, then that's okay. Because by knowing the dimensions, that we will be able to know where we want to give the refinement in that particular geometry, starting from the initial point. Okay, because we know all the dimensions of the geometry. So like this also we can fix where we want the point where we want to give the refinement. Or else if you are not aware of the dimensions and all, just we can use this paraview for visualizing, and we can move this slicing plane, and by looking the coordinates of the origin, we will be able to locate its coordinates. Okay, so this is how I had located the coordinate for giving the location mesh also. Okay, so you can now we can see one coordinate value that's inside the geometry, and it's having the value 0.03, 0.06 and 0. So if you wish, you can give these coordinates also as in the location in mesh point. So that is also lying inside the geometry, so that the geometry will be meshed. Okay, so there is no problem in that. So it doesn't mean that we need to specify a particular location for meshing in the geometry. It doesn't mean like that. We can give any point that lies inside the geometry. Okay. And now suppose I am giving the origin as 0, 0, 0. Okay. Now I am giving the origin as 0, 0, 0. What happens? Let's see. See, that point is lying outside. Okay. The point is lying outside. Got it. That ball is outside the geometry. So now in the afternoon session, we'll see how we can mesh the geometry. Uh, that means mesh the domain that's outside the geometry. Okay. So we can give the location in mesh as 0, 0, 0. Scale means what? I didn't get you. For what purpose? Is it? Yeah, we can give the lines also. We can plot the lines. We can plot lines for getting the coordinates also. Yeah, that we want to give that points over here. That we'll be discussing while we are showing the post processing. Okay, so we can use lines for getting the coordinates. Okay, that's it. And in the afternoon session, we will be discussing about the meshing outside the geometry, that's in the domain. And then we will be moving on to the solution part. Okay. So bye.